Okay, so let's move on to the next set of slides and the exercises. So we really talked about this in here, moving from these basic R graphics package and the grammar graphics, the ggplot package, and how we take this very similar structure when we use ggplot. We give it a data frame, and then we set the mappings. So how we transform columns. So these are column names in the data frame, how we transform them onto like the plotting sheet, and we can represent the data using different geoms. So here we use geom points, and here we use a histogram. And so we sort of went through. There's a wide variety of geoms. There are different ways to represent the data in ggplot2, depending on how many variables you want to plot and well, what type of plot you want to look at. So we just looked at some examples here of these different geoms, and we could see a very similar structure. On the first line of the code, we're not really changing anything, the X and the Y, we're just changing the geom, showing how the different data is changing. Here we're using just different variables to show how they're changing. And in the sort of second part, we were sort of showing this China data, which was sort of a time series data, so plotting the time on the I would say the horizontal axis, the x-axis, and using different geoms again. And then this just this point about geom line and geom path. That in geom line we follow the order on the x-axis, and in geom path we follow the order in the data. So it's the same data going in here, the same variables, but we get a different line, because in this case we're just like printing left to right the data as we go across. We're just linking up the points. Whereas geom path, we follow the order that the data appear in and the x and y coordinates based on that. Okay. And then we just talked about layers, how we can combine these geoms, and so we don't have to just stick with one type of plot. We can sort of mix, and we can also match with different data. So here we use just a red point for the last China observation here. And we talked about these sort of helper geoms with horizontal and vertical lines, and we can do even diagonal lines if we want. Okay, so the first exercise was really practice with these different geoms. So in this exercise and many of the remaining exercises, I think I explained this, we want to make sure we load this tidyverse package first. This contains ggplot2, and we will get this message at the top here telling us that it's loading this eight packages here. So when we go into the global environment, you can see there's the 7 standard packages, and then we start with the tidyverse package and another 8 packages here that are loaded up, so we can use the functions within those packages. And then what we do is use the source function that we talked about at the end of the last slides. And what the source function does is it runs an R script. So let's maybe look in the exercise. So this is running in the exercise folder. So let's see, exercise, and then what's it called? 2.1 prelim. So this is a whole lot of R code. Maybe at the end of the course, you might understand what's going on here, but it's essentially just loading the data and creating different data sets. And I'm going to close that now, and we're just going to run all the R code in there using the source function. And so what that does, maybe let me just clear the everything away, and then I'll run it again. That's just going to load the data frames that we're going to use for the plotting of the of practicing with the ggplot functions. So here we're saying just that there's 3 data sets, D, which has got countries, 104 observations for 184 countries, and we've got different variables in here for each country. And we've got the UK data, which is a time series data. Again, all this data is from the UN, and we've got the Southeast Asia data, which again is time series data, but rather than one country like the UK, it's for what is it? Maybe I don't know, maybe 10, 11 countries in Southeast Asia. Okay, so the first question was to create a scatter plot based on this data D, where we want to plot the infant mortality rates against the TFR. and we want to scatter plot. So that means we use geom point just to plot the points for each of the data points. And so this is very similar to what we had in the slides. So here we can see we get the plot here with 184 points in here. So each point is a country in the and the relationship between infant mortality rates and the total fertility rates. Okay, and then the next question was to do a bar plot. So we can use geom bar and again on D. But this time we wanted to sort of count the different immigration policies in there. So maybe we can't see it, but there's a variable called immigration policy. Let's open up D. I'll click on it. And we can probably see the whole data set. So we've got this column here, immigration policy. And then we can plot this as a bar chart using geom bar. So we just need to give it the data frame that we're interested in, and then the variable that we're interested in for the bar chart. And then we do geom bar, and we can see we get these different bar charts. So these are just counts of the number of countries that have each of these policies. So there's only maybe one or two countries we don't have data on the policy available. Maybe here we've got 20 odd that want to raise their population or raise the immigration. Okay. Question 3 was to create a box plot of the infant mortality rates for different countries from the data object D. So we've got that. The hint here is that we're going to do a box plot. So that means we need to create separate box plots for different infant mortality rates. So we're going to do that based on the continents, which is in the area name variable here. And let's see area name. Okay. So we can give it one discrete variable for a box plot and then one continuous variable for the infant mortality rates. And we can see it produced here. Okay, and question 4 was to create a line chart for the net migration in the UK over time. So on the, usually whenever we plot anything over time on the horizontal axis, we'll put a time measure. So here I've used the mid period, which is a numeric value of the period. And then we put the net for the net migration, and then the geom line, which shows the change from negative net migration to positive net migration over since 1950. Okay. Then in question 5, we want to adapt this plot. So we can use the same first 2 lines of code, but then we want to add points for each observation. So we can plus geom point, and we want to add a horizontal line at 0 net migration. So with this magic point where it moves from being a net sender to a net receiver. So we can set the y-intercept argument of geom line to 0, and that should put a horizontal line there where y is 0. So when we run it, and we see we've added these points in the horizontal line onto the plot. Okay. In question 6, we wanted to create a tile chart of the fertility over time. So when we do a tile chart, we need to, let's put this in the second line, we need to give it a x and y axes, and then also a fill color to tell us what sort of color the tile is that's going to be produced. So here in the hint, you can see the fertility data goes is based on the TFR. Country names are in the name variable, and the mid period for the X variable. Okay, so here we give it the data. The data is just the same as the UK, but except we've got multiple countries in here going over time. And when we plot it, you see we get this tile chart. So it always looks a little silly depending on how big your RStudio or your screen is, but when we press the zoom button, we can sort of see these changes in the TFR. So what the darker colors, the lower the fertility rate. So you can see Singapore going to very low fertility rates. Well, and by this time, most of the countries are pretty low, sort of less than 4, for example. You can see they're sort of changing over time. Okay, in question 7, we wanted to adapt this chart so that the country names are no longer than 15 characters long. So for example, we can see in this plot already, like the full name for Laos that the United Nations is using is pretty long, and it takes up quite a bit of the plot, right? So if we want to sort of fiddle with that, we can use this string wrap function. So before we gave it the name is going into the what's on the y-axis, and here we're going to give it the name, but set to a width of 15. That means after 15 characters, it wraps it onto a new line, and so that the sort of length of the text never goes beyond 15 characters long. So this is just like a useful little trick for when you want to sort of squash your labels down or put them over multiple lines, so you can spend more of the space in your plot on the actual data rather than the labels. So it sort of gets rid of some of the white space for you. And of course, we talk about this later about how to adjust the colors or adjust the titles. We take care of all that in the fourth exercise in the data in the slides. So let's go back to the slides. So we talked about the geoms and the layers. The next part was talking about groups. So far we sort of treated all the data as the same, but perhaps we want to play around with having different lines or different colors for different countries. So this was just an example showing for East Asian data. Here we do geom point and geom line. And there's nothing in here telling us that we should have separate lines for the different countries, right? We need to figure a way how to do this in ggplot. And so the solution is to use this group function, group argument in the aesthetics. So here we set the group to the country name, to this column here. And this allows us to separate the lines for each country to see the change in the TFR. So a common alternative is rather than use group, we might want to use a style. And then again, it will create like a separate, for example, shape for each country or a separate color for each country. So again, we pass the column that has the separate values to do that in the ggplot. Okay, so we're just talking about some of these aesthetics. They're not always going to work. So for example, if we're doing a scatter plot and we don't have any lines, then line type isn't going to mean anything. It's not going to be an option. So here's just some examples with different shapes, different colors. What do we say? Here we put the color rather than to a country name, we put the color to a time. So we get this more continuous legend. Here we put both the color and the line type to the country name. And here we're using this alpha, which is how transparent the data is. So we sort of make the older data more transparent and the newer data less transparent. And here we're using the size property. So we're putting the size of the points based on the population divided by 1,000,000. And yeah, this was just different types of aesthetics. Okay, and then the next part was, okay, let's go back to the geoms, even the grammar. So remember, right at the start, we talked about this sort of ggplot template. So we hopefully now have seen we can give it different data sets, we can produce different DMs, and we can produce different mappings. This really changed the look of the data. And then briefly, we're just going to talk about these stats and the positions. So position is useful when we do geom bar in particular, that we can change how the bars appear. So in this case, the default geom bar is sort of uses a stacked position, where when we use a fill and we put the fill based on some sort of grouping variable, then we get these sort of different colors appear for sort of the counts of each country. So there's let's say there's maybe about 5 countries here that are lower, and or maybe less than 10. Yeah, maybe 2 or 3 that are in Oceania and want to lower their population. And yeah, maybe there's about 40 that are in Africa that want to lower the population. So when we use geom bar, by default, what is written in there is position is equal to stack. But we can change that default position is equal to dodge and get a slightly different looking bar chart. And this is another alternative where we put position is equal to fill. Again, still a bar chart, but it's essentially now we sort of have a kind of share rather than a count going on here, despite the label. That's sort of a bad default behavior for ggplot when you're changing the counts. So the stats part is really explaining what is going on here. That yeah, sorry. Okay, so this is essentially when we do a bar chart, or in fact any ggplot, there's actually, we're taking a data frame and we're putting it onto a coordinate system and to create the plot. And in fact, before we put it onto the coordinate system and calculate the GMs, there's some sort of transformation. So in GM bar, we are counting how many observations there are on each fill category, for example. And then what is actually plotted is some statistical summary of the data, not the actual data itself. And so there's lots of different stats that can be used, but usually we don't need to change them, and that it behaves quite nicely. But this was just an example with GM bar, and we're plotting over time with GM bar. It doesn't look quite right. So we have a problem here, because essentially it's just counting how many observations there are. So there's just one observation with an infant mortality rate of, what is this, maybe 20 or 25 around here, right? There's only one observation. So if we really want it to work properly, then we can use the identity transformation, and then we get a proper plot, or even just use GM column, which has the identity stat as default. So that was a really a bit technical part that really you don't need to worry about too much. But exercise 2 is really just practicing more so with adding different layers on, and especially with the aesthetics, and changing how we can sort of group data together to give these different aesthetics. So let's load up exercise 2.2. Oh, that's the template, the question sheet, and load up the solutions. Okay, here we go. So again, at the start, we want to load the package and load the data using the source function. And then we want to, in the first one, create a scatter plot where we get the data as D, and then we want to plot the infant mortality rates on the x-axis, the TFR on the TFR on the y-axis, and then we want the colors to be matching the area names, and the sizes to be the size of the populations in millions. So already they're in thousands, so that's why we just divide by 1E3. So remember, 1E3 is just a short way of writing 1,000, right? 1 with 3 zeros after it. Okay, so we've got the ggplot, and we write the GM point, and then we can see we get our plot here of the relationship between TFR and infant mortality rates with different colors based on the continents, and the point size reflecting the population size in millions. Let's go back to question 2. So we want to adapt this code. So we're going to keep the same x and y axes, but in this time we're going to add a horizontal line when TFR is equal to 2.1. So we can use geom line and set the y-intercept as 2.1. And then we want all the points to have a transparency of 0.5. So rather than use A in the aesthetics part of the ggplot function, alpha, and set it to a column name, we want to set all the values to the same, so we can set that separately in the GM point, and it'll be applied to all the observations individually. So this adds the line on and sort of gives this transparency to the points here. Okay, so question 3 was to use this Southeast Asian data, and we want to plot what the infant mortality rate and the TFR, just like we had before on the X and Y axes. And then this time we're going to have the countries names as the group, and the alpha is equal to the mid period. And then we're going to use the GM path to show how the relationship between infant mortality rates and total fertility rates is changing over time. So you can see here, we've got these different lines for the different countries because we use group is equal to country name. And then we have the alpha, so the transparency of the line is dependent on the the year of observation. So here we can see the legend appearing with sort of sequence of the transparencies as the data becomes newer, it becomes brighter. Okay. So we're going to adapt this code in question 4, where we're going to, rather than use group, we're going to use color for the country names, and we're going to add on some points for the population sizes onto this point, onto this plot, and then we're going to also add on the horizontal line that the TFR is equal to 2.1, and we're going to set that line color to red. So again, just following the instructions in the question, you can see now we have different colors for each of the different countries, and we have the points based on the population sizes over time. And so we can sort of see how this relationship has changed. So for example, this was Cambodia, had a big increase in infant mortality rate, which then came back, and then a fall in TFR. So we see, it's not easy to see on this screen, but we actually have 3 axes, 3 legends on here. One is for the alpha. Up here, we just see the last bit, just like we had before. We've got a population legend, and for the point size, and the country legend for the country color. Okay. So question 5 was to sort of similar to what we had before with the UK data, where we want to plot the columns, though, of the net migration over time. We use GM column. This time we want to fill, so we want to change the color to set it to a blue for all the bars. So in this case, it's not dependent on a column name, so we don't need to write the fill here. If we're writing fill here, then we need to set it to a column in the data frame. But because we want the color to be same for all the points, then we can set it locally within the GM call function here. We can set the fill without the aesthetics functions. Okay. So in R, I think there's about maybe over 100 different color names. So you can usually guess them, or if you just Google, you can quite quickly find the color names. And in fact, there's lots of flexibility with color names that you can create your own colors as well by giving it a sort of RGB value for the red, green, and blue mix. And there's many different ways to play with colors if you really want to get super complicated with it. Okay, question 6 though was to create a density plot. And this time we want to fill the density plot with a royal blue. So again, we're going to use all the countries' data, and then we want to plot the TFR and the density plot. So let's just do it without the fill. Let's just run it without the fill, see how it looks. So we get this kind of plot. This is showing like most countries, the sort of median value of TFR is just below 2. And then we get this kind of second hump up here. Anyway, and then we can fill that bar chart, that density plot, if we like, using the fill function here. Okay. And then question 7 was to adapt this code. So rather than set the fill to a single color, we're going to set the fill to the growth policy that the country is using. So remember in this data set that it's based on. Essentially, we're using this TFR column and plotting a density of this TFR column here. Let's go back. Remember, right at the start, we've got the country names, and then we've got the TFR column. And in question 7, rather than filling the density here by a single color, we're going to fill it depending on a second characteristic in the data, which is this growth policy column. So in these African countries at the top, most of them want to lower their populations. Further down, I think we have they want to raise their populations. These are more sort of what Eastern European countries we've got down to here. Okay, so to do that, we put the fill is equal to growth policy. Okay, let's run it without this position argument here. Just see how it looks. Okay, so what's going on here is that we get individual growth policies for each of the individual densities for each of the grouping of the countries based on these growth policies. And so you can see some of them are hidden because essentially we've not used any transparency in the plot. If we want to, we can get sort of stack them together using the position argument. And in this case, we get the same overall shape of the global fertility thing, the fertility distributions that we had in the previous plot, not this plot. And we get that plot, right? We get the same overall curve, but now it's broken down by the growth policies. So this can kind of give us an idea. All the countries that want to raise their populations, they have lower TFRs, and the ones that want to lower their populations, they're more up here with the higher TFRs. So kind of making sense. So this is giving you hopefully a good idea of how the position argument is working. But by default, it was they were being plotted without without the stacking. And if we wanted to stack on top of them, then we have that option with the position argument. Okay, so that was exercise 2. And then exercise, let's see. The third exercise was based on these final sort of parts of the ggplot code that we hadn't talked about. So we'd already talked about the data, the geoms, the mappings, the stats, and the positions. And then we're just going to talk about the coordinates and the facet functions. And the third exercise is really based on these coordinates and the facet functions. So by default in ggplot, we use this, well, most plots in any function program use this Cartesian coordinates. We can give these different options in ggplot to sort of change the look or even the plotting surface that we are using, or put in some transformation of one or more of the axes. So we're just showing how we can fix the ratio between the x and the y axes, or we can flip the axes using chord flip, or here we can transform the y-axis here into a log axis. And here we're using a polar coordinate system, where sort of what was x, or what was used to be on the horizontal axis is now the angle in the circle, so where we are, and the y is the distance, how far in we are into the circle. What was y is now the distance. So this higher infant mortality rate is going to be further out. And this is really a basis of the of creating pie charts in ggplot, which is essentially bar charts where we have this fill position, and then we're going to use a polar coordinate system to put them onto a circular plotting system. That was different coordinates, and then the next part was the facets, which is one of the nicest parts of ggplot. There's these two facet functions, facet wrap and facet grid. So facet wrap is where we create these individual plot windows based on a single grouping variable, a single discrete categorical variable in the data, and facet grid, where we use 2 rather than 1 grouping variables to cross-classify the data. So this is just showing here we're creating these separate plots using the country name variable and facet wrap. Different variations on how we control the number of rows and the labels. And this is showing how we can affect the different y-axes by setting the scales of the y-axis to 3. And then this is what's showing just rather than a line chart, we're showing it with a scatter plot. And then just again, different sets of facets rather than using the continents. Here we use the development classifications and how we can really alter the scales to reflect it better. So these are all facet wrap, and this is facet grid, where here we're using cross-classifying data points by 2 of the variables rather than 1. So here we're classifying by the development on the x and on the rows, and then the growth policies on the columns. And here, this was just similar to before, but we've got 3 scales, and we're taking more care about the labels that they fit in and that they are flipping the angle of the text. Okay, so the exercise 3 was really practicing mostly with creating, how are we? exercise 2.3. Yep. With creating this pie charts and the facets. So again, we load in the data, and we can create the pie chart by setting the fill to the immigration policies for this question. And then we set the position is equal to fill. So let's just do that line chart here. So this gives us a basic bar chart just based on showing the proportion of countries in each immigration policy. Then we add the polar coordinate system to the plot to then get a pie chart out of the data, a pie chart version of the bar chart. Okay, in the second question, we were adapting what we had above. So these first three lines are the same, but then we're going to add a facet. So we're going to get these different pie charts for the different continents, essentially, right? Based on this area name column. And then we are going to use the theme void just to drop away any of the axes. We'll talk about themes a little bit later, but here you can sort of see we get the final plot out here, but we don't have any axes names, but just see the different proportions of the the growth policies in each of the countries. Okay, in question 3, I think we already had some this plot data given that we showed in the last that we built in the last exercise, but here we want to transform the x coordinates to use a log 10 scale. So we can use the coord trans function and set the x coordinates to a log 10 scale, which then you can see has on this a log transformation to the horizontal scale, to the infant mortality rates. Okay, and then in the next part we are going to adapt the code above, but we're going to add facets to the how we were saying for each continent to have their own facet, their own window. So it's quite simple, right? We can just adapt with this one extra line, the facet wrap function, where the facets are going to be based on the continent or the area name column. So again, the same plot as before, except we separated the points out so that on each of the each facet contains only the countries in the specific continent. So here we've only got, I guess this must be the US and Canada in North America. Okay, and then question 5 was again adapting above, the code above, but using a different way to facet the data. So before we just faceted the country based on the area, but this time we're going to facet based on the development status. So we go back to the data. We've got this developed column, just saying whether it's a more or less developed country. So yeah, we've got some. So we've got Australia, New Zealand are more, Fiji, Papua New Guinea, for example, are less. So that's based on the UN definition. And we're going to set the scales to equal to be free for the y-axis, and we're going to set them to be arranged into one column. So remember, when we use facet wrap, it automatically tries to fit them into sort of a rectangular shape, but we can control that using the n column and n rows if we really want to have more control. So here we've got the two facets for the two different development levels, and then yeah, we've set the y-axis to be free. So what is that saying? So these are the y-axes. So you can see for the less developed countries, it goes between 1 and almost 8, and for the more developed countries, it goes between 1.2 and 2.2. Let's just see how that changes when, for example, we get rid of the scales free. You'll see that they'll have the same scales in the plot. So here they both take the same common scales when we don't set the axes to be free for the y. Okay, so I'll just go back to this now. So this is what we had before. Let's get rid of that. Okay, and this last part was to use, rather than use facet wrap, we use facet grid. So again, this is, remember, our basic scatter plot that we've got. And this time we're going to create a facet plot, arranging these sort of separated parts of the scatter plot based on the cross classification of the points by the developed variable and the growth policy variable. And again, we're going to set the scales, the Y scale, to be free, and we're going to wrap the labels so that they are no longer than 15 characters. So let's see how this looks. So this 15 character thing was making sure that these labels are not getting too long for their section. And then you can see the data is now cross-classified by both the development level here, the less or more, and the growth policies here on the columns, reflecting the code. Okay, so that was the end of the exercise 2.3. And then the last part was talking about different finishing touches. So how can we alter the scale, the different aesthetics, sorry. So we can alter, for example, the fill color or the shapes or the sizes. And we can create different palettes for colors using different scale fill functions. So we can base them on specific fill, specific color palettes, or we can create our own. So for example, we use our scale fill gradient to create our own range of palettes, our own palette of color based on the lowest value taking a pink color, the highest value taking a sky blue color, and the middle value taking a white color, and we tell it what the mid value is. Okay, and then the second part here was on labels. So here we can really get towards the finishing touches of the plots, where we can give the title and the subtitle. We put in a caption here, and we can give proper labels to the legend. So the aesthetics they used in the fill. So by default, that would say area underscore name, taking the column name, but we can change it to something a bit more easier to read, a bit more professional. We can also change the X and Y axes using the all in the labs function. So this is for the labels. And then here we talked about the themes. So by default, right, we've always had this gray background here. So it's not the nicest sometimes for plots, especially if sometimes you might be submitting to a journal or some kind of publisher that wants a plain background. So you can use this theme BW for black and white background. This is the default. You can have sort of a more minimal themed or a void theme that we saw a little bit earlier. So this is just an example where we just add on the theme black and white to the previous plot without the labels. And then saving the plots, here we can see we can save the plot as a R object, and then we can use ggSave, and then we can set the file name that we want to save the plot to, either as a PNG or a PDF, and we can define the width and the height for the final output of the plot. And we can play around the scale function, which tells us how big the text is going to appear in the plot. So this was with the scale is equal to 2, and this was the scale is equal to 1. But that scale is all relative, remember, to the width and the heights of the plots. So if you have a bigger plot, it might look fine. You might not need to change the scale. And then the final part was about combining plots. So here we create two plots and we save them as different R objects. So here we have a G1 and a G2. And if we want to combine them into one plot, we can use the patchwork package. So here we do G1 plus G2, and we put them besides each other. And we use the plus, and we use the sort of divide, the slash, and they put it underneath each other. And we can change the sort of ratios of how high they should be using the plot layout, or we can use the widths using the plot layout as well. And here we're sort of even having a bit more complicated layout where we have this sort of main square, first plots, the A's, and the B plot is just up here in the top right. And this part is empty where we use the hash and the cheat sheet here. So the exercise 4 was really playing around with with these different labelings and the themes that we have in the data. And I think we'll do a bit of patchwork in the exercise. Let's have a look. So again, we load the data, and then we uncomment the code below. So this is what we had before. The basic that we were playing around with the in the facet function in the previous exercise. And now we're going to change this, the colors. So we're going to set it to the set one color. So that was back in, where were we? Back here. We're going to use the set one color here. So this is a special name that this color palette takes. So we can set the palette using scale color brewer. We can set the scale sizes for the breaks in the population in the sizes. So here you can see, sorry, I think it's a bit easier. Here we only have two parts in the population, how do we say, legend. If we want to have a bit more detail there, then we can use this scale size continuous function, and then we can set the breaks. So rather than here, the breaks are 500 and 1,000 by default. 1,000? Yeah, 1,000. 500 and 1,000. But if we want a bit more detail, then we can set that manually here. Yeah, let's just run that, these two edits on their own. Okay. So here we've changed the colors, and then we've got these breaks according to how we define them in our code. Okay, and then the last part is just adding the labels for the X and the Y axes, the colors, and the size. So you see here, for example, for the size, we got pop divided by 1,000. It's not the most professional looking label. So here we can change it to population brackets M for millions. Right? And we can get the final plot out ready to save. So the second question is just practicing saving the plot. So here we can save it where we can set the file name, and we can set the width and height. And for example, here we put the scale is equal to 2 to double the scale. And so once we run that, then it's saved it in the exercise folder, and the plot is called myplot1. So if we want to open it, we can go to the exercise folder. And here you see it's just appeared myplot1. So we can click on it here, and it should open up. We've got the final plot out here. Okay. Well, and below, okay, if we want to save this step of scoring through the file directory and finding it, we can use the file show function, and that will automatically open it as well. It's another way, a quick way of working in R and seeing the plots. So for example, if we want to change the scale function just to see how it works, we can do that here. Do the file show. You can see the, the text size is a little bit too big, so that's why I set it to 2 by default. Okay. Okay. So in question 3, we wanted to use the code that we had before, but we wanted to use a black aesthetic. So let's see what we had was, okay, yeah, what we had before was this kind of tile chart. But here we've added some more detail based on these instructions. So we've added this black aesthetic for the tile borders, which has given us the lines on the outside. So let's get rid of it just to see how it works. So here you see we've got no kind of border colors there when we don't use it. And we set the fill as equal to the net migration in millions. So I think the fill is here. Let's put it all on one line. It's zoomed in so the text is too big. Okay, so we set the fill to the net divided by 1,000, sorry. Let's see, we wanted to use the period as the X variable, and then the Y as the country name, but wrapped just like we did in that previous exercise. And then we want to send the object to the, save the object. Yeah, I think this should be save the object to object G. So we're going to name it, and you see, once we run this code, nothing actually updates, but it's saved here in G. So when we actually run the code for G, we can see the final result. And in this case, why might we want to do that? because perhaps we just want to play around with it and see how it changes. So in this case, we're going to change the fill gradient. So rather than having the default blues, we're going to set it from red to red for the low values, black for the high values, and white for the zero values. So kind of like a counting framework, right? So when the net migration is negative, then we get these red values. When it's positive, we get this black values. And when it's kind of towards zero, then we're getting the whiter values. Yeah. So you can see we can update the plot code, right? All we did was take the original object G, and then we add on the different fill, and it updates the object when we run the whole code, right? When we've saved it here, G. Okay, so now when I run the G, it's all updated, and we've sort of lost the blue colors. And then this further enhancement is adding the labels to it. Okay, so we're gonna add the labels as just copying and pasting from what's written here for the title, the X and the Y axes, and the fill. So rather than, for example, having net divided by 1,000, we get the net migration in millions as the label. Oh, is that coming out? Here we go. Oh, it's a bit funny. Let's open it up again. Okay, there we go. So we've got the proper axis titles on there. Okay. And then the last part is just to use the minimal theme. And so let's have a look at that. So you can see we've got rid of some of the gray background here. It might have been interfering a bit. And then this last part is just to alter the angle of the text. So you can see this wouldn't be like a nice plot to really put in a paper because there's overlapping text here, so it's really difficult to read. So this last bit is just a trick to rotate the text. So this is something that you end up doing a lot, but I never remember exactly how to do this. It's something that I just have to Google pretty much all the time. It's just essentially what we're saying is in this theme function, there are many different options where you can basically change everything about the look of the plot. And so here we're changing the x-axis text, and what we are doing is adjusting the angle of the text to a 45-degree angle, and we're having a horizontal alignment at 1, which means at the end of the text rather than the start of the text. This creates this effect here where you have this sort of 45-degree angle on the x-axis labels, so we can sort of fit them all in. Okay, and then again, we're just saving them, and this time we're saving as a PDF with these different widths and heights, and yeah, there we see, and we get the final plot out here, so looking fairly nice in a PDF. Okay, so that was exercise 2.4. Where were we? Back in the slides. Yeah. Move this out there. Okay. Close this one down. Okay, so I think that was the last slide, wasn't it? Yeah. Okay, so maybe that's a good time, yeah, to take another break, and then afterwards we can go again back onto the data manipulation code and their exercises. So let's take another 10-minute break. So if we come back again at let's say 5 past, and we can start to go through the next set of exercises.